Good evening. I am here to present Yacc, the yet another a compiler and compiler. In a previous video, I discussed a lexical analyzer. Lexical analyzer that recognize regular expressions, or the regular expressions are used to arrive at the patterns. So these patterns are used to recognize or to generate a tokens from the input stream. Now we have the another a tool, that is the Yacc. It is the yet another a compiler and compiler, which processes and performs a semantics processing on the tokens. So today I'll be discussing on the yet another a compiler and compiler. The Yacc takes the tokens and so group these tokens together logically. So then the purpose of the Yacc, it takes the grammar, then a construct a parser, that constructor that construct the parser, a parser recognize a valid sentence or not for your input. A grammar use the productions or the grammar as a set of productions. The yet another a compiler, the yet another a compiler and compiler uses a grammar. A grammar are used to specify the programming constructs. The programming constructs includes a statement or the flow control statements or the any statements of a language. Now here is the example of a grammar. The example of the grammar where the statement so the statement means a statement can be an expression, or so it is an expression which assign the value of expression is assigned to the variables. So that is constitute the statement. So a grammar as the productions. The productions are of the form the left hand side of arrow is called as the left hand side of the productions. The right hand side of the arrow are called as a right side of the productions. There can be multiple right hand side productions, but only one left hand side a symbol, left hand symbol. So here the expression that is derived as a number, a plus a number, or the expression can be defined as number minus number. So to understand this, let us consider the example. So here is an example, that 12 plus a 13. 12 plus 13. It's an expression. The expression is of the form a number, a plus a number. So this expression is evaluated. The evaluated expression value is assigned to the variable answer. So this constitutes a statement. This is called as a statement. One example for a statement. Now, when the input, when a given input, when a parser reads the input are placed on the stack. So in this for this example, the first it is the input. The first symbol in the input is answer, that is passed, that is placed on the stack. So the second input and third input, then fourth, that is the first, second symbol, a third symbol. Then in this way, all the symbols are placed onto the stack. So once all the symbols are placed onto the stack, a parser, that is the Yacc parser, a construct a parse tree. The parse tree is constructed in this way. The number, it is here in this example is a 30, and another number it is in this example it is a 12. So this number, it's a token. It's recognized by lexical analyzer. A lexical analyzer returns a set of tokens. That tokens are recognized with help of the patterns, and patterns are written using regular expressions. When the tokens are returned by a lexical analyzer, and these tokens are used in the Yacc. So in this way here, the number is this number is a token written by the Yacc lexical, and so this number, a plus number, that constitute an expressions. Then so this expression is the assigned to the value of the expression is assigned to the answer. So that constitute the statement. The parser tree construction starts with the number and its values is 13, and so here is the another number, its value is 13. That's is so then so this the number it matches with the right side of the production, and this number matches to the right side of the production. The number plus number, the number plus number matches to the right side of the production. Whenever as such a right side of the productions are matched, it is reduced to reduce the symbol reduce the symbol on the left side of the production. So therefore here the number plus a number is reduced to expression, Then further the expression matches to the right side of an expression, the right side of the expression. So right side of the right side of the the first production. So this is the right side of the production. So since it is a match, then whenever the input matches to the right side of the production are replaced or reduced to the symbol on left hand side. So therefore the expression is reduced to the answer. In turn, this answer is reduced to the statement. Let us see how you can use this grammar and the set of productions to perform the calculation, the arithmetic calculations with an example. The Yacc, another a compiler as three different sections as similar to the lex analyzer, lexical. The first section in the Yacc is a definition section. In a definition section, the all declarations, the C programming, the C code declarations are enclosed within the percentage floor bucket and percentage floor bucket. So not only the declarations, even the definitions the function definitions, then the symbol definitions, so can be included in the definition section. It has got, we can say, there is this is the percentage start. So this can be used to say the which symbol is used as a start symbol of a production. Then the percentage tokens, a set of tokens that is returned by the set of tokens returned by a lexiconizer is specified using percentage tokens. Then if there are the different tokens and each token has different types of values, to specify different types of the values of a tokens, the percentage union is used. In the similarly, now to specify a type of a token, the data type of a token, the percentage type can be used. So these are the options. These all options are available. The first option is percentage start, to say a start symbol. The percentage tokens, the set of tokens returned by an lexiconizer. To specify the type of the token, we can use the percentage types. To see the different types of the tokens, we can use the percentage union. These are the options are available. So make a note that here the operators, it is plus, the minus, the assignment operators need not to be declared in the definition section. The the example here, the token, the percentage token indicates that the name and number of the tokens are generated by lexiconizer. So these tokens are generated on the request of the Yacc of the parser. You move on to the next section. It is the rule section. The rule section of a Yacc consists of a list of a grammar rules and then followed by the action associated with the grammar productions. The example here is a list of a grammar rules. To say it's a statement, the productions are represented this format. The left hand side of a production is present before the colon, and right side of the production is presented after the colon. If the right side of the production has a multiple options, or the right side of the production has multiple the right side of the productions, then that is indicated with this particular line. So that is, a statement can be defined as a name is equal to expressions. That is, the expression is assigned to the variable, or the statement is can also defined as it's an expression. Now the definition of expression is given as, the definition of expression is given as the expression, the colon indicates the expression derives a number plus a number, or a number minus a number. A number, a plus a number is an expression, or the expression can be also defined as a number minus number. The multiple options are specified using this particular lines. So this is the one way of specifying the grammar rules. In the the rules section of the Yacc. There are the symbols are used in the Yacc. So the expression has got different symbols. Any value of a number or the value of an expression is always a numerical value of a number or its expression. So if there is a name, it's the name identifier. The value of such identifier is refers to the symbol table pointer. Then the different symbols they use the different symbols as different data types. The value of the symbols depends on the data type of the symbols. A commonly the int and float double are used to represent a numerical symbol values, and character pointer, that's the character is used for the string. The rule section of the Yacc, it executes the codes associated with the rule. The parser reduces the rule and it executes the code associated with the rules. The code associated with the rules means this is the rules. It says the production of a grammar. Then the C code, the C code, that's user code associated with the rule, means the C code that's enclosed within the parentheses is called as the C code associated with the rules. When the production are recognized, or when a production for this production, the corresponding the action is specified in the user C code. So in this case here, if the expression is evaluated, and so if you want to print the value of expression, we can use the printer statement to print the value of the expression. Now the input statement is recognized as an expression where the expression is expressed as the expression plus a number, or the expression minus number, or the expression. So now, to know what are the values associated with the symbols, the value that's associated with the left hand side symbols are represented by double dollar. The value that's associated with the right side symbols are represented as $1, $2, $3. So depending on the number of symbols that's present on right hand side, the $1, $2, $2, $3 represent the correspondingly the symbols on right hand side. So before I take the examples for the next the Yacc, the lexer are used in the Yacc program. The lexer provides the set of tokens for the Yacc. The Yacc, or it's a parser, it's the I-label routines, and this I-label routines it calls a lexer through the y/lex method. Whenever a parser calls a lexer with the y/lex, the lexical analyzer is invoked. The lexical analyzer finds a tokens, and these tokens are returned to the parsers. The code, there's a token code as the value for these tokens are returned to the parser. And the token that is written by Yacc, the tokens written by lexical analyzer are stored in y.tab.h. Now, so in this slide, so I'm going to present the lexical specifications for recognizing a number. This is the regular expression for recognizing the input as a number. If there is a white space is present in input, that white space are ignored. Ignoring the white space is done using the regular expression /t. In the same way, if a new line character is present in the input, it just returns 0 and go for next line. Any other than this new line, a task space, or a numerical characters, it just returns a 0. It returns a zeros. So the next, stores the value of a tokens in the YYL value. The YYL value is a function which store the value of a token. So these lexical specifications are used in the Yacc program. So that is illustrated in this example. So this is an example of the arithmetic expression. The arithmetic expressions are represented using a grammar productions. A grammar productions are presented as in this way. The first production expression is defined as the expression plus expression. The value of a symbols that are present on left hand side are stored in $. The values of the symbols that's present on right hand side are stored in $1, or they are stored in $2. In this way, they are stored like the first variable on the right hand side are stored in the $1. The next symbol is stored in the $2. In this way, the sequence is followed. It is the arithmetic expression productions where the expression is defined as expression plus expression, or it is the or. The expression can be defined as the expression minus expression. So when the code is written in the flower bucket, the enclosed in the flower bucket indicates the evaluation is the C code, the user C code, the evaluation of this expression. They evaluate the symbol $1 minus $2, $3, and assign this value into $. And similarly, the expression can be defined as the expression, a star expression, and evaluate this expression in this format. So take the value $1 and multiply with the $3 values, and result is stored in $. In the same way, if expression is in the form, the expression divides the expression to check whether the expression has a divide by a 0. So that is checked using the statement if a $3 is equal to 0. If $3 is equal to 0, that means it has a divide by 0. If not, you compute a $1 value is divided by $3 and value is assigned to $. So sometimes the expression can be just expression is defined as the unary minus expression. In that case, the value after 2 is assigned to $. And sometimes the expression is also defined as the expression enclosed within the parentheses is assigned to the expression. So in that case, the $2 value assigned to $. Or the expression can be just a number. So in that case, take the value of number and assign to $. Now, in order to specify the precedence for operator to avoid the conflicts, that arises during the evaluation of expression, the Yacc provides the option to specify the precedence for the operators, the precedence for the minus and plus, the precedence for multiplication and symbol, and precedence for the URI minus. So based on this precedence that is specified, the precedence order is maintained or used in the evaluation of the arithmetic expression. A third section of Yacc contains the C code, and this C code supports the language processing such as the symbol table implementations, then a function that might be called by the action associated with the productions, and this production, the actions, the associated productions are declared in the second part of the Yacc. The C code means the implementation of the functions are defined in a third section of Yacc. So let us take the example that computes the that computes the or that act as a calculator, arithmetic calculator that computes the value of an expression. For that, here is a program. The first start of the Excel analyzer, a definition for the definition for Excel analyzer, as in this may include the various declarations finds. So then here is the expressions, the real expression for defining a number, the regular expression to ignore the space, a regular expression for ignoring the new line character. So then followed by it is then followed by it is WRAP function. The Yacc part where it has the first section is definition section. The definition section as in the definition section we can specify the finds to be included and the list of definitions of variables, the definition for a functions. So in this with respect to this example here, the definition for the tokens, a definition for the precedence, then so here and there are some variables that is declared as the phi equal to 0. This is the definition of the variables. So it is a definition for a token. Definition for the token. This list of tokens returned by lexiconizer is specified as percentage token in number. The rule section of a Yacc consists of the statement that is a production that defines the arithmetic expression is defined as E, then followed by the user C code statements. The user C code statements is that specifies the action to be taken when the arithmetic expression is evaluated or is determined its valid expression. The expression can be defined as the expression plus expression. So if this expression is recognized, then evaluate this expression with $1 as a first operand, $3 as second operand, and plus is an operator that's represented by $2. The value of this expression is assigned to $. If the regular expression is the form the E derives E, then so evaluate this expression using this format. It is $1 represent operand 1, $3 represent operand 2. So then this minus is present by $2, and evaluate this expression assigned to $. So in this way, there are the different way, the different forms of the expression, different forms of the expression. When such expressions are evaluated, the value of this expression is assigned to double dollar. Here is the third section. A third section of a Yacc contains the C code statements. So in this example, now here is the printf statement. The printf statement is used to ask the user to enter the arithmetic expressions. It can have operations which can perform, which can have the addition. It can have operations like as addition, subtractions, multiplications, divisions, or any of this. So when such expressions entered by the user, the YY parser function is invoked. When a YY parser function is invoked, then the X, that is a Yacc parser, the functionality of the Yacc is invoked. So then it just uses the set of functions that's specified in the rule section. If the given input matches the set of functions, then the corresponding expression is evaluated and then return the results. So if the flag equal to 0, that indicates that the input entered by the user is a valid expression. If whenever this flag equal to 1, that's indicated with the indicate as its invalid expression. To say this invalid expression, that is the YY error a function is defined. So it is today we have discussed about the Yacc programs and the structure of the Yacc programs. We'll continue our discussion with some more examples in the next section.